Hi, and welcome to the Engineered Mind podcast, a podcast about engineering, AI, neuroscience, and other interesting topics of life to educate and inspire people all around the world. I'm your host, Jousef, and for this podcast, I welcome Cyprien Rusu. Cyprien is a French engineer who loves to share his burning passion about the Finite Element method to help engineers all over the world. He has been using FEA for more than 10 years now, and he would like to change the way FEA is taught in order to make it more accessible to engineers and designers who really need it to improve their products. With his blog, FEA for All, he is creating content in FEA courses for everyone interested in learning FEA. And now, ladies and gentlemen, happy learning with Cyprien Rusu. Okay, Cyprien, thanks a lot for accepting my invite for this spontaneous podcast. So what we will start with is just give us an introduction to yourself and what you do and who you are.
Well, thanks to you first to invite me to do this kind of podcasts. I'm always glad to discuss with other engineers, and really, this is a great opportunity to share knowledge about engineering, FEA, and a lot of stuff. As I saw that you are also doing a lot of great stuff in this area. So, but like you said, let me introduce myself a bit for the people who don't know me already. So I'm currently Director of Engineering Asia in OnScale, a company doing cloud simulation. But I'm mostly known right now for my blog, FEA for All, in which I teach engineers to become really good in FEA and to go basically from basics to an advanced level. Because there is a lot of crap going on in the area. And I'm trying basically to skim all of this to teach people in a simple way, good practices, things to do, and really how to understand and how to do the right stuff. So this is something that I do on my blog. I have a YouTube channel that I'm also doing for a lot of years and posting a lot of videos, tutorials, all this kind of stuff. And about myself, well, you can say I'm an engineer. I think it's obvious, right? I fell in love with FEA since I went into engineering school in France, in the École Centrale de Lille. And since I never stopped to simulate all kind of application, all kind of physics of systems. And I'm always amazed of what you can do with simulation and FEA. Mm-hmm. And I just try to teach as much as I can what I know to all the people. That's why I have this blog and this YouTube channel and all the things I'm doing. And besides all that, well, I love learn languages. I can currently speak 6 languages, including Korean, Chinese, Japanese, a bit of German, but really a bit. English and French, which is my first language. And and so some people say that I have some kind of talent for language, but I don't like this term. Mm-hmm. We can talk about what we want. And beside that, I like a lot of things, photography, for example, or a lot of other stuff. Mm. So I think that resumes more or less what I've been doing. Let me know if you have questions.
Yeah, that's great. What made you stuck with FEA? Why not, for instance, CFD? Although it's almost the same, we can say, but what made you stuck with FEA? What fascinates you?
Well, FEA and CFD are 2 different things. CFD is basically computational fluid dynamics, right? Mm-hmm. So it's a numerical method which can be based on FEA as well. Yeah. Because you can use FEA, which means, for those who don't know what FEA means, it means finite element analysis, right? So it's based basically on an FEM, which is finite element method, and CFD can also be based on finite element or finite difference. So there are several methods. So I didn't really choose between FEA or CFD. I'm doing both, actually. If you look at my blog, I have some tutorials about CFD as well. It just depends on my mood, let's say.
Okay.
when I want to do some CFD, I do some CFD as well. But really, it really depends on what I have on hand and what I want to teach people.
Mm-hmm. Can you walk us a little bit through your career path, like where you started after you graduated?
Yeah, sure. So I did a double degree in France and in China.
Mm-hmm.
And after that, after I finished my degree in the Tsinghua University in Beijing, I went to work for Midas IT, which is, you can say, a medium small company in Korea, like 500 people, developing Korean simulation software. So it's like those are software which are also based on FEA, mainly for civil engineering and geotechnical. So at the beginning, I was doing geotechnical kind of simulation and analysis. And then I went to mechanical. And what happened is that they were just developing this software called Midas NFX, which was a pretty generalist kind of software for mechanical simulation, including CFD, including a lot of stuff. And they had no one in the international team to handle this and to basically help for this business. So that's when they just asked me, Cyprien, do you want to do that? And okay, I was a bit full, but I was young. I took this opportunity. I said, okay, let's do it. And they gave me this software, but the software was in beta, and there was basically nothing going with it. All the tutorials were in Korean. The presentation about the software were in Korean as well. They gave me a video of one of their VP speaking in Korean about the software, and they basically told me, okay, listen to this video and try to understand what he's saying. And I was like, okay, let's start like that. So I started by looking at the Korean interface and the English interface to try to understand, what all those features meant. And really, when I was just graduated, I already had some experience about FEA that I had done in school or in university, trying to do some kind of projects and stuff like that with Abacus. And I thought that I knew a lot about FEA. But, when you're young, you tend to think, okay, I know a lot. And then that's when you're basically crushed by the world, and you realize that you know nothing. And you have to start from zero to learn again all the stuff. So I went with this software. I had to learn, because this is very generalist software, so there was everything into it. All kind of simulation, linear, non-linear, dynamic, frequency-based, explicit, fast dynamic, and CFD. And, all of that was like pretty new for me. I had done a bit of linear, a bit of non-linear static, but that was all. And they just gave me software and said, okay, Cyprien, you have to make all the training materials. You have to train people over in the world. You have to find us some partners everywhere in the world. And, so I had to start from scratch to go all over all those stuff. And it was hard at the beginning, but it was really, really fascinating experience. And it was a Korean company, so everyone was speaking Korean. I was an international team, so they were a bit more, Anglicized, but still, I had to. That's why my Korean became much better after that. And I was the guy who basically had to, let's say, market. And because I started with the technical stuff, but really I switched to business very quickly because they needed some guy to do this kind of stuff. And they basically put me in charge of the team to spread the software in the world. So I had to do all the advertising, I had to do all the marketing, all the sales. I was doing the phone calls to the people, and I was doing webinars all the time. Like we had 2 webinars per week. So 1 month I had around 10 webinars per month to give. So I think in 4 years I did something like 300, 400 webinars. So
that's crazy.
it was really crazy. crazy stuff, but definitely very interesting. And so that was when I started, and I became just even more and more interested into FEA, and that's when I decided to launch my blog. Because everyone who starts and do FEA has to go through this process. So why not tell everyone what I know through my blog, to share my experience, teach everyone else, and it's good for everyone. It's good for me. It's good for them, and this is really interesting. So I started to do that, to publish videos, to teach people. And afterwards, after Midas, I went back to China. I worked for some time for EDF, the electricity company in the nuclear field. So I was doing also some mechanical simulation for nuclear kind of systems. And now 2years ago, I went to OnScale, where I started to do the as engineering director Asia for OnScale, because like I told you, I speak a lot of Asian languages, so I'm very efficient to find the good people in Asia and to present the software and to also solve problems in various languages. So, yeah, that's it.
That's great. That's great. Going back to FEA, what if now a newbie in this field watches this video? How would you explain to him or to her, why would we need FEA? Why is it necessary?
Okay, so that's a very good question, because why we need FEA? Well, you have to consider that as engineer, what is the purpose of an engineer? Engineer basically build things. We are builders, right? We create new things from scratch. We create systems. We create reality. So you need to have some system in place to help you to do that, some tools to do this. And when you design a system, you design something. It's especially when it's a mechanical system, the worry is basically, will it work? Will it crash? Will it be destroyed under certain circumstances, under certain kind of loads? And you understand that if you are an engineer in a business which has very high stakes, like you can think about nuclear, you can think about aerospace. If you design a plane, you design a nuclear power plant or stuff like that, it cannot fail. You cannot take the risk then something breaks loose and a bolt breaks loose and everything explodes, right? So you have to be sure 100% about your job and about the accuracy of what you're doing. So and those systems are so big that you cannot say, okay, I will build a prototype and I will try to see if it breaks or not. You cannot build a power plant prototype and hope that make it explode to see if this will work. Mm-hmm. So that's why in these critical areas where you really have some dangerous systems, that's where FEA is the most important, because this allows you to basically make virtual experiments on your computer. So instead of going out in the wild and making some prototype and trying to break it with some machinery, you're just doing the same stuff, but inside your computer. And this allows you to take no risks at all, because you're able to break things and look at how it breaks simply by using your computer.
Mm-hmm. So what we are basically doing is some kind of simulation, right? We would try to mimic the real world. How do you think, let's say, if we have a complex loading on our component, and we cannot really mimic that or implement that into our FEA software, how do you think, how can someone manage the real world behavior?
So there's always a difference between the real world and the model, right? Because we want always to get as close as the real world as possible, but we have to be aware that what we get on the computer is not the real world. It's a model of the real world. There are assumptions, approximations behind stuff. Mm. You have system, the mechanical system you have, always have some kind of things which are simply not real, because for a lot of reasons, you cannot model 100% reality, and there are several reasons for that. Some reasons is that sometimes it's just too complex to model reality because reality has so many phenomena and physics involved. And the second reason is, do you really need to simulate all that?
Mm-hmm.
So, because why would you simulate a fluid behavior over an airplane if what you're interested in is really the stiffness of the airplane itself? You can simply approximate the airflow by using some load. So you can say this is an approximation of the reality, but there will always be an approximation. So to answer your questions, there is always a way to simulate the loads that approximate the real world, let's say, because what are the kind of loads that exist in the world? There's only a limited choice, a force, a pressure, moment, and then you have all that depending on time, temperature, and all of that are physics that are modeled by the solvers and different kind of loads. So of course, you're not always able to do it within a certain software, because maybe this software has some limitations, but that's another topic, right? It depends on the implementation of the people who have developed this numerical code.
Yeah.
If you suppose that you have full access to the software, you're using something open source, for example, and you can develop the numerical method you need to use and to change the loading, well, I would say that you can do pretty much whatever you want.
Mm-hmm. Are we living in a simulation? What do you think?
I don't know.
You don't know? Okay. So let's say someone wants to do an FEA analysis, and of course, a lot of people trust what they see in the computer, right? They see maybe red numbers, like red legend. Maybe it breaks, yes. Maybe it doesn't break. How far of a good engineer do you have to be to really understand what the computer shows you? Like you also have to put in your own expertise, right? You cannot trust the computer itself.
Yeah, of course. So how good engineer you have to be to understand what you see inside the computer. So you have to be aware of certain stuff. First, do you mean someone who modeled something himself inside a software and then look at his own result? Or do you mean someone who look at a simulation done by some expert who know what he's doing and then doesn't understand the result? What do you mean?
First, if he's doing it by himself and then looking at the results and then saying, okay, I did it, so it must be right. And I trust the computer. How do you see that?
Okay. Okay, that's a big problem, because I think a lot of beginners have this kind of mindset that they don't understand how the software and the algorithm behind work. So, they tend to think that computer cannot be wrong, or whatever I see on my screen is correct. Of course not. Of course not. What is an FEA software? A software is just a tool which basically if there is a graphical interface, it's just a way to translate the physics and the algorithms that are calculated behind in a graphical way, so you see what happens. But if you think about the algorithms in themselves, do you think that algorithms are always right? Of course not. There are a lot of assumptions that are involved. Algorithms have to converge towards a solution, and you have to use the right algorithms as well. So if your software doesn't implement the right algorithms, and if it doesn't do things in the right way behind the screen, the software can be wrong. So it totally depends on the software, but I'm not saying most of the time the software is not the problem, right? Most of the time the user is the problem.
Yeah, definitely.
So I'm just saying that the software might be wrong as well, but most of the time the main problem comes from the user, and it comes basically from the fact that people want to do something very quickly without having to think too much about what they input into the tool. So, but really what is important in FEA is the input you give. If the input is wrong, if the material properties you're using are not correct, of course you get something which is not correct at the output. So there's a principle for that called the garbage in, garbage out.
Right.
And beginners tend to ignore this fact, and they just like, okay, I'm following a tutorial or something. They tell me to do like this, but tutorial is just one example of what you can be doing. But everything depends on your model, on what you want to simulate, what you want to do, what kind of application you have, what kind of physics is involved, what kind of assumptions you're doing, the size of your loading, the type of boundary condition you are using, the mesh size. All this stuff are important. So you obviously have to know in some way all of this to be able to simulate something correctly. So saying that if you don't know anything and you just throw a model into your computer and you look at the results, I would say 90% of time this is wrong. So, but there is a way to kind of come back to reality and see if this is correct or not. It's to compare that with experiment, of course. So if, let's say, you are comparing what you see on the screen with a real experiment, and you are doing a matching of those results, well, then you get some kind of way to evaluate and to compare reality with your with the simulation. And if you get this way to compare, then you have a way to say, okay, I'm wrong or I'm not wrong. And of course, it takes also some knowledge to do experiments the right way. So you need to have that as well. But that's the way I see beginners who would like to know if their result is wrong or not could do. Now, what I always tell to my students and people who read my blog is, take the time to understand how this works. Take the time to understand the system. Don't rush to a solution or just clicking a few buttons. FEA software is an engineering tool. It requires some reflection, some thinking about the physics. It's not a Word or MS Word processor. It's not about doing something quickly and you see immediately a result that you can judge like that so quickly. It requires a lot of experience. So to answer your first question is, how experienced you should be. Well, you should be experienced enough. That's what I want to say. You should be clear about the engineering method you use, and you should be clear about the physics which is involved, and you should know what is stress, what is a displacement, and you should have those basics in order to at least judge. And always keep in mind that you can be wrong. Computer can be wrong as well. Most of the time you are wrong. So try to, let's suppose that you are 90% wrong all the time, and that if you keep trying and if you keep using the good method, maybe one day you will start to be less wrong until it will start to match real results.
That's good input, Cyprien. Thanks a lot. There's this famous 10,000 hour rule, which says once you reach that 10,000 hours, you're kind of an expert in this field. Do you believe in that? And do you think it's applicable for simulation, for the field of simulation?
Yeah, of course. Well, like I think it's who said that? It was I forgot the name of the guy who told about this 10,000 hour rule. But I agree with this, and I disagree at the same time. So what I want to say is that if you spend 10,000 hours, it's sure that you will be an expert. But you can be an expert without necessarily spending so much time. So So it really depends how much, how much you are focused on this, and how much you are focused on relearning the stuff and trying to understand this. Because, if you spend 10,000 hours, it really depends on your concentration, every day. If you're just learning, 30 minutes for several years, well, you will become an expert, of course, after several years. But if you really do the job to read a lot of books, to ask a lot of people questions, to understand what you do, to do a lot of practice, this can go really fast and much faster than you think. So I would say it really depends on the people and your background and what you really want to achieve on that.
I see. So let's say someone wants to delve into the field of FEA. What resources would you recommend to him or to her, apart from the software? Software doesn't matter first. What resources would you recommend to get started or to delve deeper into the field of simulation?
Well, to get started, you can start with my blog, of course.
Yeah, of course.
So, and it depends what you want to learn. Ask the right questions. Read a lot. And actually, I have one rule to learn something is, in my opinion, the best way to learn something is really to find the best book you can find on the topic, and take some time to choose a good book, not the first one you can find in the library or something, but really something which has been recommended by a lot of people, and just take this one book and spend some real time to read it, chapter by chapter, do the exercise and go over the stuff, practice a lot, ask some people. And if you do like that, you will become a proficient very, very shortly. And if you have some doubts or anything, you can send me some questions.
Yeah, of course.
I have a lot of people asking me this question actually through the blog or through YouTube. I have a basic free course also on the blog. So you can really. There's a lot of way to learn. It depends on your own motivation.
Very good. Thanks a lot, Cyprien. There's a lot of abbreviations in the field like CFD, FEA, FEM, CAD, CAE. Can you explain the difference between CAD and CAE? What the difference is?
Yeah, of course. That's maybe something that as a real beginner, you're wondering. Like you say, you have a lot of abbreviation. You don't really know what it means. Well, CAD means computer-assisted design, and CAE means computer-assisted engineering. So the difference here is really between design and engineering. So when you talk about design, it's more the graphical aspect that enters into play. So you're thinking about basically making the CAD of the model, the graphical model, the geometry. So CAD is about designing the geometry of your system in terms of shapes, lines, nodes, and all that. And CAE is about applying engineering methods to do some virtual testing on this geometry. So those are two different aspects. In the CAD process, it's just about creating a geometry. So it's 100% about the visual aspect of it. Like, how do I make my faces? How do I, generate this kind of shapes? And CAE is about, okay, now I have this virtual geometry. How do I transform that into a numerical model? And how do I do some virtual testing? Like, how do I apply loads? How do I do some tests of the stiffness of this model, of the strengths, and how do I get out some results that I will need to understand the physical characteristics of this geometry.
What would you say? What are the barriers of FEA? Where's the limit of FEA?
Well, when I started really using FEA, infinite element analysis, I always wanted to think that you can simulate everything. Now, so in my opinion, I still sometimes think that there's no real limits to FEA because everything depends on the engineer imagination. If you really need to simulate a system, you can always find a way to do it, to make a model which will be more or less accurate and to understand it. But you always have to think that the limits of the model and the simulation is the physics, right? You cannot simulate something which will be unphysical. And you always have to stay in the bounds of reality and in the laws of physics. And sometimes that's something that, people who don't understand the physics, they want to get out, they want to simulate something. But sometimes it doesn't even come to mind that this might be unphysical. And that's the problem, because this is totally 100% virtual. So we can take any model, we can put any kind of load and just look at the results. But, in reality, will you have this kind of airplane with this kind of huge load on it? Never, And so if you stay within the bounds of the reality and the physics you are simulating, I think FEA can give you the right answers. Now, if you really want to dream and to make some science fiction, then better to try some After Effects and to make some cinema movies than some FEA.
Yeah, that's good. I want to also give you some philosophical questions. Okay, what I like to ask is, let's say the phone rings now in your room and you pick it up and 18-year-old Cyprien is on the phone. What would you tell 18-year-old Cyprien? Some tips about life, about simulation maybe. What would you tell him?
Okay. That's a very good question. So let me 1 minute just to think, because I've never thought about that. What I would tell myself, I don't think I would tell myself anything actually, because I think life is much more interesting if you don't know what is happening in the future. And it's always some kind of discovery for me, learning new stuff all the time, and going from one thing to another, learning new ways to think, new ways to evolve. And I believe that what is important is the process of this learning, and you cannot jump from point A to point B. If someone tells you something like 20 years after, and this is critically important for your life, well, if this is important for your life, like, I don't know, don't go in this plane because it will explode like in the movies, then I probably tell it to myself, of course, but I'm talking more, in a realistic way. I'm not dead right now, so obviously I can give some advice to myself. And what I mean is that, what is important is the learning with serendipity. So I don't know if you know what is the meaning of serendipity. It's kind of the concept that you basically want to learn something, and on the way to learning this thing, you discover 3 or 4 new things that you weren't aware about it before, and you start to go in this direction, and after some time, you discover that, wow, this thing that I was never even aware about, it's so great, it's so interesting, and it can change the world so much that, I want to learn that. And then you repeat over this process for several years, and, and you start to see that you are kind of evolving towards a certain direction and learning very interesting stuff. So my only principle is just, if something is not working for you, just ditch it out, throw it out. Don't spend too much time, doing things that do not work or do not interest you. Go in the way which has the maximum learning for you. That's my philosophy, let's say. Because some people ask, what is the easy way? What is the way to do this kind of stuff easily? I never ask myself this question. I always prefer, the hard way, which is to learn things in a very difficult way, because I believe that this brings you a lot of stuff on the way that you simply cannot foresee these things in the future. And if I was telling me this in the past, I just wouldn't listen probably to myself in the future. So it's useless when someone tells you something. You have to discover it by yourself in order to really take it seriously.
Mm-hmm. That's great. Yeah,
it's like, I don't know if you have this experience, but it's very. I have a lot of people. I tell them, you should absolutely read this book, and most of people, like 99%, they're like, okay, yeah, I'm surely I have to read. And then, what happens is 5 minutes after, they just forget about this.
Mm-hmm.
But when someone tells me this, and I trust this guy, what I do is that I immediately buy the book and I start to read it. And if this is bullshit, I just drop the book. But if there are interesting things in this book, I just learn from it. So always try, to experience things.
Mm-hmm. Great, Cyprien. What is fulfillment for you? What gives you fulfillment? What would you say?
Well, I would say learning a lot of complex things, and just enjoying the result. If you learn some new methods or some new language or some new things, at the beginning it's hard, but after a few years you realize that you can do those things so much faster than anyone else. So it's just enjoyable to improve your skills and to improve your mind, to think faster, and to and then you will always discover that there are always people who are more intelligent than you. So that's even better because you can learn from them.
Oh yeah, you're completely right. I think it's if you're the smartest one in the room, then there's something wrong, right? So I wouldn't like to be the smartest one in the room. Definitely not. Anything else you would like to let the people know about you as a person, apart from all this kind of simulation stuff, and what should people know about you? Well,
they should know that I really like to talk to people and to help people to do things. So really, if you have any question, you need any help on some things, you're free to contact me. I cannot guarantee that I will always answer you because I receive thousands of emails every day. But really, if there is some interesting problem and if I can really help on something, I'm always happy, to receive some emails and comments from other engineers.
That's great. It's great. So we know each other for like over 7 years now, and it was really a pleasure talking to you. And I will put every link to your blog, of course, which is great, and also your YouTube channel down in the description. And in case you want to contact Cyprien, I will put just everything down in the description. So it was great talking to you, Cyprien. Hope you stay safe and healthy.
Yeah.
And I would say see you soon, hopefully.
Yeah, thank you, Jousef.
Bye.
And stay safe as well.
Yeah, thanks.
Bye.